Hey everybody, Shane from Norman S. Wright. In a meeting last week, we were talking about minimum VFD settings for fans, and I thought it'd be a good topic to discuss this week. So let's talk about the minimum VFD setting on a fan and what happens if you go below minimum. Let's get started. VFD stands for Variable Frequency Drive. As a quick reminder, a VFD controls the speed of an electric motor by varying the frequency of the power it sends to the motor. I covered VFDs in one of my early videos, so I'll put a link to that below. In North America, motors typically run at 60 Hertz. So if the VFD is at 100%, it sends 60 Hertz to the motor, and the motor runs at 100% speed. Turn the VFD down to 30 Hertz, and the motor would run at 50% speed. So let me move this up. Using a VFD on a fan allows you to match demand to maintain comfort or your process needs or your ventilation rates. When you reduce a fan's speed, the energy use drops significantly. If you remember from the fan laws video, which I'll also put a link below too, the fan laws are that the CFM is proportional to the speed of the fan, so CFM2 equals CFM1 times RPM2 divided by RPM1. The static pressure changes with the square of the speed of the fan, so static pressure 2 equals static pressure 1 times RPM 2 divided by RPM 1 squared. And the horsepower changes with the cube of this fan speed. So brake horsepower 2 equals brake horsepower 1 times RPM 2 divided by RPM 1 cubed. So I'm just going to make up some numbers to put in here. Let's say CFM 2 equals CFM 1, which is 5,000 times, I'm just going to say 50% because we're just cutting the motor speed in half. And that'll equal 2,500 CFM. So a 50% drop in the speed results in a 50% CFM drop as well. And let's say the static pressure starts at 3 inches, and now you take your 50% motor speed change and square that, and you get 0.75 inches, and that's a 75% reduction in static pressure. And then for, let's say, 3 brake horsepower, you take your 0.5 cubed now, and that's 0.375 horsepower. So that's an 87.5% reduction in motor horsepower, which is a lot. Let's move this over again. So there isn't a set turn down that works for every motor and fan combination because every motor fan combination is different. Not every motor and fan combination will operate safely or efficiently at very low speeds for several reasons. From a performance standpoint, some fans' performance drop off steeply at low speeds. Below these speeds, they might not generate enough pressure to overcome duct resistance, or you could have unstable flow or fan stall. Let me move this up just a little bit more. Different fan types perform differently at low speed. This is why some motor fan combinations might be able to turn down to 20 Hertz when others may only be able to go down to 25 Hertz. Let's slide this up again. Also, many motors are air-cooled. When the motor slows down, less air flows over the motor to cool it. So if you run too slow for too long, your motor could overheat. And slower motor speeds can reduce the effectiveness of internal lubrication in motors as well. There could also be resonant frequencies or vibration problems if a VFD is turned down to the fan's resonant frequency. In this case, you might want to program your minimums higher than that or skip this frequency. Let's slide this over again. So you can see here on the fan data sheet that it shows minimum VFD limit. So you want to make sure that this is set correctly in operation. Let's bring everything back on screen. So that's why fans have minimum VFD limits and what can happen if you go below them. If you have any questions or suggestions for future videos, put them in the comments below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.